Okay, here's a little bit of help with what we did on the Jamboards in class in case you're confused, okay? So the first thing was when we did just the skater, okay? So we had the skater, okay, and the skateboard can be part of the skater, right? Because it's kind of attached to him. It never leaves him. Skater, ramp, and earth, okay? If you want to include ground, you can, right? It's kind of irrelevant, but if you want to, you can. Okay, so the skater is touching the ramp, okay? And then the skater and the ramp interact with the earth because everyone interacts with the earth, right? And if you want to include the ramp to the ground, you can, but that's kind of optional, all right? And then we're really interested in these objects, okay? And we want to include the earth in the system. We would like the earth to be part of the system because the earth is kind of why the skater's falling in the first place. So it's sort of important. All right. State diagram, you can draw it however you want. I'm just going to draw it real simple. Okay. The first state that I wanted was with the guy on the ground. And I'm going to go ahead and draw the earth in here. I don't think we did this in class, but probably a good idea to put it. Okay. In the second picture, we've raised the guy to the top. And I'm also going to put the earth underneath there. Okay, and in the final state diagram, I wanted the guy when he was coming around the bottom. Okay, all right, so there's my state diagrams. And in these dotted arrows here, we're going to put in the objects in the system. And you don't have to connect them up with arrows. If you want to, you can, sort of like a system schema, but you don't have to. Okay, all right, so if we look at this middle position to start with, okay, we have some different energies here. We have EG, which is the gravitational energy or the separation from the earth. All right, kinetic energy, which is moving, energy of motion. Elastic energy, which is anything that's like stretched or compressed or squished. And then thermal, which we didn't have in this first example, okay? So I'm going to put little X's for EE and ETH because those aren't involved. And at the top, the guy was not moving. All right, so all of his energy is going to be stored as EG. So I'm going to put 5 boxes of EG. You could put 3, you could put 4, you could put 2, you could put whatever you want. It doesn't matter. It's kind of an arbitrary choice. All right, and he's not moving at the top when he's first released, so there's no EK. All right, after we let him go, and then he makes it down to the middle of the ramp, okay, there's still no EE or ETH, all right, and he's now on the ground also, right, so we're going to call that ground level an EG of 0. Okay, that's kind of like the base position where we're going to say there's no separation with the earth. Okay, even though that's kind of an arbitrary choice. All right, and he's moving now really fast when he's coming across the bottom. So if I have 5 bars of EG over here, I have to keep the same 5 bars over here. Okay, because that is all going to be transferred, all the EG to EK, because it has to be somewhere. It can't go away. All right. And then the important part of this one, if we look at the beginning, right, we don't have any energy here because the guy is on the ground. He's at that EG equals 0 level. He's not moving, and there's nothing stretched or compressed to like propel him up, right? So there's nothing here. So he has no energy, and then all of a sudden he has 5 bars of energy. Okay, and that's not allowed, right? You can't just create energy out of nothing. Something had to happen. Okay, so in the simulation, right, we kind of took like say the hand of God, picked up the guy and dragged him to the top, right? That's how he ended up here at the top. Okay, somebody had to do work on him to move him to a new position, all right? So the way we draw that is going into the system, 1, 2, 3, 4, 5 bars of work, and we call that work, okay, or working. I'm working on the system and adding energy in. So if I add 5 in, now I have 5 and I still have 5. Okay. All right. So if I'm going to have this hand here, right, I'm going to have to include that in my system schema. But the hand is outside the system, right? Because the hand is not included in here, right? The hand is sort of out here doing work on the system. So I'll put the hand here who touches the skater, okay, but from outside the system, okay? All right, so that's how you could get the initial energy in the first place. It has to still come from somewhere, okay? In this case, we say that the hand did work on the system to give it energy. Okay? All right, so that was the first example. Now, the second example, all right, we want to start the analysis when the skater's at the top left. Oops, let me draw that a little different because I want to leave some room for the ground, and I'm going to leave some room for the earth. Okay? Over here. Okay, and then two other places. All right? Okay, and then this time we went to the friction version of the simulation, and now we have this thermal energy, right? Because of this rubbing between the skateboard and the ramp, that is making it hotter, right? So that's transferring energy to the storage of thermal, right? Meaning that it's hot, okay? So it's kind of like heating it up, sort of. All right, okay. All right, so I'm gonna, again, have the skater, skateboard, kind of the same thing, okay? The ramp is actually really important now because that interaction here is what's causing that thermal energy transfer, okay? And of course I want the earth, okay? And then again, the ground, if you want it, kind of irrelevant to the ramp, right? So I'm not really gonna include that in my system because the ground is sort of doesn't matter, okay? All right, and this time I don't need any hand, right? Because the guy already has energy when it starts. So the guy already has 5 EGs when we start. We just didn't look back here at the position before where we may have had to do work on the system. All right, so he already has it. Okay, so we're gonna have skater, ramp, and earth. Okay, and then let's pick 2 more positions, right? So I'm gonna pick maybe the position here when he's at the bottom. Okay, and then the position over here when he's at the top again on the other side. All right. Okay, so if he's moving across the bottom here, let me fill in all this, skater, ramp, and earth, okay? He has 5 bars of EG, so I still have to have 5 total here, okay? So he's moving now. He's on the ground. There's nothing elastic. So I'm going to take away 1 of the EK boxes, and I'm going to add it into the thermal category, right? Because he's still moving very fast, okay? But some of that energy has been sort of wasted in that rubbing and that creation of heat energy between the wheels and the ramp, okay? So that's kind of wasting some of that energy, all right? And then the next position I'm going to pick is maybe like the top on the other side, okay? Right? And if I already had 1 bar of thermal energy, I have to keep it, okay? Because the thermal energy can't go back and transfer to something else. It's just kind of wasted, right? It just sort of made everything in the system a little bit hotter. And you can't really harness that energy to transfer it to something else, okay? Right? And the rubbing on the surface as he moves continues. Okay, so he is maybe gonna get another bar of thermal energy by the time he gets to the top on the other side because he's wasting more energy the whole time that it goes. Okay, so if I still have to have 5, I only have 3 left that's available, right? So that means I can only have 3 EGs if I say he's not moving and there's no springs. Okay, so when I look here that he had 5 EGs to start and now he only has 3, this is going to mean that he's going to be at a lower place than he was at before, right? Because he's not as high, he's not as separated from the earth as he was in the beginning, okay? And that's because all of this thermal energy has been wasted in that creation of heat in that rubbing process, just like your hands in the rubbing hand station. Okay. All right. And you can pick any 2 other positions you want. Okay. Just as long as you're being consistent. Okay. So things that have to be true. Okay. EG is bigger when higher, right? More separated from the earth. The EK is bigger when you're faster, right? So you kind of have to relatively check them. Okay. And the ETH always grows, right? It can never get smaller. It just continually gets bigger. Or in some cases stays the same, but mostly just continues to get bigger, okay? And then the energy is conserved, okay? Meaning it always stays the same in every state, okay? Every time I do a new state diagram, I have the same amount of energy present that there was in the state diagram before. It just might be distributed differently among the different ways that energy is stored, okay? All right, so hopefully that was helpful. There you go.